Welcome to level 8. We've made almost everything negative in our equations here in this section. Last thing to make negative today is constants, so please make this the title on the next free page in your math notebook. When you have done that, you know the drill. Mark the page, close it up, and concentrate. All right. So last time we dealt with negative coefficients. As we go through these titles, variables, constants, coefficients, I want you to get used to. This is called a variable. It's an unknown value. And the last time we made the coefficients negative. That tells you like how many of the variable you have. So last thing today is constants. We're going to make those negative. Today we haven't done that yet. Just a reminder of some of our strategies for negative coefficients or anything else we've solved so far. This one, if we drew it, since you can't draw a negative number of n's, that's not a possible thing to do, we draw 4 opposite of n's, like this. Then we draw our constant of 13, then our total of 25 over there. And our first move is to take 13 away from both sides. After we do, we're left with the 4 opposite of n's on one side. And 25 take away 13 is 12. So what we did was this weird last step where we kind of said, okay, I'm not going to find n yet. I'm going to find the opposite of n. Each of these 4 opposite of n's here would have to be 3 in order to make that true. So that means the opposite of n is 3 based on what I found. So n would be -3. And that's our actual solution, because that's what you're always trying to find out. What is the variable itself? We also use inverse operation strategy. It's a bit more straightforward when it comes to this negative coefficient business. We took 13 off both sides, equals 12, and then we divided by -4. And as long as you know your positive negative rules, 12 divided by -4 also n equals -3. So today we're going to be working on making this constant or negative rather. Before we do, I want to remind you how we dealt with negative, subtraction. One of the ways was called add the opposite. So when I have, say, 20 minus, we'll just do it. 20 minus 10, of course you can do that. The add the opposite strategy with subtraction tells us that's the same as 20 plus -10. Those are the same. And I'm going to encourage that today. Subtracting gets you into a lot of trouble in equations, so I'm generally going to say just don't do it anymore. Just whenever you see a subtraction sign, change it to add the opposite. You get the same thing, and you're far, far less likely to make a mistake. So let's do that. So here we go. Here's our first one where our constant is going to end up negative. So that is actually what I'm going to tell you as the first thing to see. If you see subtraction in one of these variable equations, that should like warn you, uh-oh, I'm really, really likely to make a mistake. Let's not bother with it. I'm going to rewrite the equation with add the opposite so that I don't run into that issue. I'm going to write it as -3x. Instead of -40, I'm going to do plus -40. Promise, I know it's weird, but I promise it will make you less likely to make a mistake. Equals 20. So you don't have to do this. I'm going to just show you because I think it's going to be easier, especially with the visual strategy. I just think you're a lot less likely to make a mistake. So when I do that, here's why. If I want to employ the visual strategy, -3x or 3 opposite of x's. Here it is. I don't know how to draw take away 40 on the visual strategy. I don't know how to do that. I do know how to show plus -40. And so that's what I want to do. I just think that's a lot easier to show than trying to show -40. And of course, 20 here. Okay. So another tip now. Now what we want to do, obviously, is get rid of that from that side in the visual strategy. We like to have just our variables by themselves. Here's how I get rid of a -40. I could just take away -40 and do 20 minus -40. That's fine. Subtracting with negatives can be a little finicky. So I'm going to show you another way to do it. So if you don't want to do that and say, okay, I'm subtracting negative 40 here, and I'm subtracting negative 40 here. Another way that you can do this to get rid of this negative 40 that is, I think, simpler to understand is instead of taking it away, I'm going to add something onto that side that will get rid of that. I'm going to add a positive 40 on that side rather than taking negative 40 off that side. You can do either. But if you do that, you put negative 40 on that side, boom, it's gone. That'll just make 0 and it's not there anymore. So of course, if I do it on one side, I'm going to do it on the other. And so that's going to be kind of my trick today. When you've got a negative constant, I think the easiest way to deal with it is to add the opposite to each side rather than taking that off each side. So if I do that, those are going to make 0. That was the whole point of it. And now I've got 3 negative x's on this side, or opposite of x's rather, and this side's going to have 60 because I'm 20 and I'm putting this 40 we put there. If you did 20 minus negative 40, you'd also get 60. I just think subtracting is a little more error prone, so I don't usually do it. So now I'm ready to solve this. I've got 3 of these opposite of x's. To make 60, they'd each have to be 20. So if the opposite of x is 20, then that means x is negative 20. Solved. Okay, inverse operation strategy. Again, a lot of this business is not so complicated on the inverse operation strategy. So 2 ways to do it. I'm going to first use where I don't change it to add the opposite, where I solve this original one. I'll also talk about solving it if you do that. So negative 3x, take away 40, equals 20. So here's option 1. I'm just going to leave it how it was. I'm not going to do add the opposite. I'm just going to operate with it like this. Same old thing. I've got 2 operations. I've got times negative 3, which will turn into divide by negative 3. And I've got minus 40, which the inverse will be plus 40. And of course, I'm going to do them in reverse GEMS order. So that first, that second. So first thing I'm going to do is add 40 to both sides. Minus 40 plus 40 goes away. Plus 40. Notice this is exactly what we did over here. We added 40 to both sides first. And you get negative 3x equals 60. Now I'm going to divide both sides by negative 3, which is what I did here. 60 divided by negative 3 is negative 20. Okay, so that's like if you just leave the subtraction in there. Since I'm advising you not to, let me show you how it works the same way, even if you don't. If I go to this equation instead of the one I started with add the opposite, I'm going to end up doing the same thing. So negative 3x plus negative 40 equals 20. So remember, my first goal is always to get rid of this. And a way to get rid of negative 40, just like we did here, is to add 40 on both sides, which is exactly what we did the other way too. You could, if you wanted, again, subtraction just gets weird, you could subtract negative 40 from both sides, which is the same thing. But again, that just gets, I just don't like it as much. So a lot of times, rather than, when I've got a negative, rather than subtracting it, I'll just add the opposite of it, because that's still going to go away. And then I'm still going to get negative 3x equals 60, which is still x equals negative 20. Okay, I'm a bit short on time, so I'm going to skip the check. I don't advise skipping the check, but I have a time limit on these videos, and I want to make sure I don't super rush you. So here's what we do. Go ahead and pause here and write this down, and unpause when you're ready to go. Okay. So if we use the visual strategy, I'm always going to advise that you rewrite this with add the opposite. So negative 35 on this side, it's going to be 5x plus negative 10 if I use add the opposite. Rather than trying to show minus 10, which I can't do, I'm going to show plus the opposite of 10. there. So here's your new part. To get rid of this negative 10, I have two options. One is you can take away negative 10. That's fine, as long as you do it properly over here. I think that's trickier than instead of that, when I have negatives, I like to put the opposite on that side. I like to add a 10 to both sides because that's still going to make those go away. That's my whole point in doing it. But I think it's easier than trying to subtract negative 10 mathematically. So I'm just going to add a 10 to both sides. Now those kind of go away. Pretty cool. So negative 35 now is equal to 1, 2, 3, 4, 5 of these x's, which means each x has to be negative 7, I believe. So x equals negative 7. So that's the visual strategy. Inverse operation strategy. Again, this one's very reliable. I don't know if this is the one you're getting more used to. I understand everything better with the visual strategy, but the inverse operation strategy tends to be easier. It doesn't actually change very much from lesson to lesson. But I like you to have two. You know, every once in a while you'll run into a problem and your preferred strategy just doesn't feel right. And it's nice to have another one to fall back on. All right. So negative 35 equals 5x minus 10. So usual business. What's happening to x? It's being multiplied by positive 5. The inverse of that will be dividing by positive 5. It also has 10 being subtracted or negative 10 being added. If you want to change it with add the opposite, either way. Either way, the inverse will be adding a positive 10. Whether this is minus 10 or plus negative 10, adding a 10 is how we'll get rid of it. So in reverse gems order, this is first and this is second. So first step, add the 10. Add the 10. Oh, I made a mistake in my drawing strategy. I just saw it. I'm so sorry. I guess I better go back there. I didn't add this, did I? Whoops! If I had checked it, or when I checked it, I would have caught that. Well, I guess I need to go back and fix that. So sorry. Let's do negative 35 plus 10 would make this negative 25. Didn't even see it. Which would mean each x would be negative 5. Not negative 7. Sorry about that. Okay, carrying on over here. So now that's why I just saw it, because now I know I need negative 25 here. And those cancel out, and I have 5x. Divide both sides by 5. And x equals negative 5. Ta-da. I feel good that I've got it when both my two strategies match, but I'll go ahead and check to be safe. So if I'm right, and I use substitution to check, then I should get that negative 35 is equal to 5 times negative 5 minus 10, which would mean multiply before you subtract. So negative 35 should be equal to negative 25 minus 10, which if I use add the opposite is the same as negative 25 plus negative 10, and it is. And that, y'all, is how you solve a variable equation with a negative constant in it. Hopefully that makes some good sense to you. If not, please, please, please give this video another watch. This is one of the harder transitions to make because you really have to be confident with your negative numbers here and really understand them, not just be able to mechanically do them. So if you need to give this another watch, go ahead. If not, you're ready for you to do together, and we'll see you on the next one.